So moving on to the tests we did. The methods for this testing included a participant cycling for 20 minutes at resistance on an ergometer bike. They were supposed to have no warm-up so that we could see the effects of exercise more clearly. And we would take heart rate every minute, blood pressure every 4 minutes, oxygen saturation every 2 minutes, RPE every 4 minutes, breathing rate every 2 minutes, and lactate every 4. This would hopefully give us results that we could relate to the cardiovascular system, the respiratory system, and the energy system. So moving on to the data now then. For summer and max, there's an initial increase in heart rate as exercise begins. For summer, this increase was plus 72 beats per minute, and for max this increase was plus 30 beats per minute. We would consider Josh's data to be incorrect, as he doesn't follow the trend of both the other participants and the expected data. His heart rate decreases by 34 beats per minute, as opposed to increasing. Therefore, I would disregard his first recording. To correct and evaluate this abnormality, we would perhaps retest using the same method. In relation to heart rate, normative data would show an initial increase in heart rate as exercise starts. The heart rate would then plateau after approximately 3 minutes. Summer and max's heart rates show slight correlation to what is expected of normative data, as both heart rates show little fluctuation after 4 minutes. Josh's data again doesn't correlate with the other participants in relation to the expected plateau, as his heart rate continually rises, increasing from 71 at the start of exercise to 177 at the end of exercise. After this plateau, and as exercise finishes, we would expect a large decrease in heart rate as they should be working aerobically, so they should recover easily due to lesser oxygen debt. All participants show this decrease in heart rate as exercise ends. However, the decrease is not as quick as normative data would suggest. Furthermore, Summer's heart rate only decreases by 10 beats per minute, and a further 15 beats per minute after she exercises. We would expect the decrease to be a lot larger, as those fluctuations could be considered plateau. Max's decrease was a similar decrease to this. However, it's a little bit steeper, whereas Josh's only recorded post 1 minute and not post 2, so you can't see the full effect of the decrease. However, by looking at the graph, you can see that from the transition between the 20th minute and post 1 minute, the decrease is fairly similar to Summer's. Oxygen saturation data. As the exercise begins, minute 2, Summer and Max's results are both at 99%, whereas Josh's was 97%. At 10 minutes, both Josh and Max's were at 97%, where Summer's remained at 99%. At minute 20, Summer's and Josh's had dropped to 97%, whereas Max's oxygen saturation had increased to 99%. Normative data suggests that oxygen saturation in steady-state exercise should remain between 98% and 99%. The only time that oxygen saturation levels might fall is at the start of exercise. This would be a result of the demand for oxygen at the muscles not yet being met. However, after approximately 3 minutes of exercise, the oxygen saturation should plateau to levels of between 98 to 99%. The demand for oxygen is being met due to the aerobic nature of the activity. Therefore, at the start of exercise, in the first 2 minutes, Summer and Max's results don't show the initial increase of oxygen saturations that normative data suggested would happen. However, normative data suggests this initial decrease doesn't always occur. Therefore, Summer and Max's aren't drastically different to what normative data would suggest. Josh's data does show this initial decrease in oxygen saturation, as his levels dropped from 97% after 2 minutes. At 10 minutes, Summer's O2 saturation correlates with normative data, as her levels sit at 99%, suggesting she's working aerobically. Josh and Max's levels do not correlate with normative data, as their levels were at 97%, where they should be 98 to 99. Finally, at minute 20, Summer and Max's levels do not correlate with normative data, as they fall again to 97%, where Josh's does correlate with normative data, as his levels are at 99%. Breathing rate. As exercise begins, Summer's breathing rate rises, as do Josh and Max's. Summer's increases from 16 to 24, Max's increases from 40 to 44, and Josh's increases from 26 to 34. At minute 10, Summer's, Max's, and Josh's breathing rates all begin to plateau. For example, Summer's plateaued to 33 breaths per minute from the 29 2 minutes before. At minute 20, they all decreased slightly, but could still suggest a plateau, as the maximum difference in breathing rate was in Max's, which was a difference of 4, not that significant. Whilst there are some increases and decreases at points, the general trend of the data is that your breathing rate plateaus after about minute 6 to minute 8. This correlates slightly with normative data, as normative data would suggest a plateau when steady state is reached. However, normative data suggests that this plateau should occur at approximately 3 minutes, earlier than that of what data shows. After exercise finishes, you can see that their breathing rates begin to fall. This is expected and correlates with normative data. However, as we only recorded post 2 minutes, we cannot see the full effect of this decrease and how steeply it ended up decreasing and how quickly it returned to normal. That's perhaps a fault in our method, an experimental method. Lactate data. Both Summer and Max have an initial increase after 2 minutes in lactate levels as exercise begins. Summer's increases by 12.5% and Max's increases by 16.2%. Josh's differs from the other participants, as his lactate levels only increased by 0.5%. Josh's lactate relates more closely to normative data, as you wouldn't expect an increase in lactate levels in aerobic exercise, especially one that dramatic of Summer and Max's. After the initial increase at the start of exercise, Summer and Max's levels of lactate seem to slightly plateau, as they only increase slightly. Summer's increases by 3.8% and Max's by 1.2%. Again, Josh's greatly differs from the other participants, as his is extremely low, correlating with normative aerobic exercise data. Josh's lactate levels only increase by 0.6%. Both Summer and Max's lactate levels decrease between 10 to 16 minutes. Summer's decreases by 3.4% and Max's by 7.8%. Josh's also decreases slightly, but only by 0.2%. In the final stage of exercise, Summer's lactate levels increase by 4.3%, where Max's decrease by 7.5%, and Josh's increases by 1.5%. In general, this data does not correlate with normative data. Josh's could be seen to correlate with normative data, as his lactate levels remain very low throughout. However, Summer and Max's are extremely high for what you would expect of steady state exercise due to the aerobic nature of the exercise. Lactate levels should not be that high, as there should be a sufficient supply of oxygen to the working muscles, meaning they shouldn't be using anaerobic glycolysis, which creates that lactate. RPE data. None of the participants show any patterns with their RPE. However, all of their RPE ratings were fairly high, with results above 10 throughout. This obviously implies that they all feel as though they're working extremely hard, which would suggest that they're working anaerobically, as aerobic exercise should not make them feel as though they're working hard. All of the client's scores fluctuate throughout, at different points and at different levels. This shows that there is no correlation with normative data whatsoever, as normative data would imply that their RPEs should remain fairly low as they're working aerobically, and they should remain consistent as there is no increase or decrease in exercise intensity, meaning they shouldn't feel as though they're working too hard. This lack of pattern would perhaps imply that we should disregard this data. During our experiment, the whole process seemed very rushed in getting their RPE scores from them, and the actual list of what the RPE scores meant was very far away. This meant that our participants found it difficult to actually read off what RPE scores there were, which is a flaw in our method, which could be changed in future if we were to retest. The final factor that we recorded was blood pressure data. Due to experimental methods in one of our experiments with our client Josh, we didn't record much data on blood pressure for him, as we only recorded, I think, 2 intervals, whereas Summer was the most recorded and Max still wasn't equal on the amount of recordings we received for him. The data from the tests shows no pattern for any of the participants, and therefore cannot correlate with normative data. Furthermore, Summer's blood pressure shows abnormal levels, so I would disregard the data for blood pressure. Both systole and diastole separately for each have some faults and show some abnormalities, so I cannot use this data to create any recordings or any conclusions.